All right, let's talk about a scientist who was, well, a total unicorn. A guy who was a master of both mind-bending theories and getting his hands dirty with experiments. His name was Enrico Fermi, and his work didn't just win him a Nobel Prize, it completely changed the course of history.
Okay, so picture this. It's December 2nd, 1942. A phone call is made from a secret lab in Chicago. The message sounds weird, right? But what it meant would change everything. An Italian navigator had just finished a historic journey.
To figure that out, we've got to go back. We need to understand the man behind that secret code. This is the story of Enrico Fermi.
We're starting in Rome, 1901. Enrico Fermi wasn't just a smart kid. He was on a whole other level. I mean, as a teenager, he was teaching himself cutting-edge physics from old books in Latin and German. He basically left his university professors in the dust.
You know, his understanding of physics was so deep, so intuitive, that his colleagues gave him this incredible nickname. When the Pope had something to say about physics, you listened. His word was pretty much considered final.
And here's why he was so respected. See, most great physicists are either thinkers, theorists, or they're doers, experimenters. Fermi, he was a master of both worlds. On one hand, as a theorist, he was coming up with things like Fermi-Dirac statistics, which describe a whole class of particles we now call fermions. But on the other hand, he was totally at home in the lab, figuring out how to create new radioactive elements. That kind of dual genius is just incredibly rare.
But Fermi's amazing career in Italy was on a collision course with history. As the political situation in Europe got darker and darker, his greatest scientific prize would become his family's only ticket to freedom. So the year's 1938. Fermi gets the call. He's won the Nobel Prize for his groundbreaking work with neutrons. It's the highest honor a scientist can get. But for Fermi and his family, it came in a moment of absolute crisis.
Because that exact same year, Mussolini's fascist government passed a set of horrible racial laws. And these laws were a direct threat to Fermi's wife, Laura, who was Jewish. So suddenly, that trip to Stockholm to pick up the Nobel Prize, it wasn't a celebration, it was an escape plan. After the ceremony, they never went back to Italy. They sailed straight to New York and to a new life.
Fermi gets to America just as the world of physics is being turned upside down. News breaks that German scientists have discovered nuclear fission. And Fermi, well, he was one of the few people on Earth who could immediately grasp the terrifying power this unlocked. All that work he'd done in Rome suddenly had a new, terrifying urgency.
And here's one of the craziest ironies in science history. It turns out Fermi had been wrong about his Nobel-winning discovery. Those new elements he thought he'd created, they weren't new at all. He had accidentally been splitting uranium atoms the whole time. He'd been achieving nuclear fission without even knowing it. So the work that won him the Nobel was based on a misunderstanding, but that very same misunderstanding gave him the key to the next world-changing step.
So leading a top-secret team for the Manhattan Project, Fermi did something nobody had ever done before. He designed a pile. And I mean, it was literally a massive stack of 400 tons of graphite bricks and uranium, and he built it in a squash court under the stands of a university football field. Then, on that day, December 2nd, 1942, his team slowly pulled out the control rods. And it worked. They achieved the first self-sustaining nuclear chain reaction in human history. The Italian navigator had just landed in the New World.
But Fermi's genius wasn't just in these huge, complex projects. It was in his incredible intuition. Picture this. He's at the Trinity test, the first ever atomic bomb detonation. While everyone else is just stunned by the raw power, what's Fermi doing? He's running an experiment. He's just dropping little bits of paper and watching how far the shockwave blows them.
From that simple back-of-the-envelope calculation, he comes up with an answer, a blast yield of 10 kilotons. Now, the official, super sophisticated instruments later measured it at 18.6 kilotons. Using nothing but scraps of paper, Fermi was amazingly close. It just cemented his legend as a physicist who could almost feel the answers. After the war, Fermi's influence just kept growing. He was a key figure in establishing the national lab system, but his curiosity was boundless. It reached way beyond the atom, to questions that we are still wrestling with today.
I mean, his name is now written into the very fabric of science. You've got an entire class of particles, a fundamental cosmic question, America's top particle accelerator, an element on the periodic table, even a space telescope, all named after him.
But you know, maybe his most famous legacy came from a totally casual question he asked over lunch one day. He thought about the size of the universe, all those billions of stars, and how likely it seems that life should be out there. And then he pointed out the big, unsettling problem, the silence.
That contradiction, we now call it the Fermi paradox.
And so we're going to end with the question that he left for all of us. It's simple, it's profound, and it perfectly sums up the spirit of Enrico Fermi, a man who changed our world forever just by asking the right questions. Where is everybody?